Welcome back. Now we're looking at 8.3 special right triangles continued, day 2 in class practice. Okay, there are 6 problems that will either use a special right triangle or the Pythagorean theorem to find a missing side length. Now, you should have gone through numbers 1 through 6 on your own and attempted each of the problems. Okay, if you have not done so, stop the video. I want you to try these on your own first. Once you've tried them on your own, then I will go through the problems with you. Okay, problem number 1. Find the length of the diagonal of a square with sides 10 inches long. Okay, first of all, I have the shape of a square, and we want to find the length of a diagonal. I'm going to first draw a square. Now, in a square, I know I have 4 congruent sides, and a square also has 4 right angles. Okay. Now, this square has sides that's 10 inches long. So that means each side of the square is 10 inches. I need to find the length of the diagonal. So I'm going to draw in one diagonal. This is what I need to find the length of. Now, because a square is a rhombus, when I draw in a diagonal, the diagonal bisects the angles. So what this creates is 2 45, 45, 90-degree triangles. Okay, I'm going to focus on the triangle on the top right. If this is a 45, 45, 90-degree triangle, then I know that my leg times radical 2 is equal to the hypotenuse. Now, I need to find the length of my diagonal. I'm going to call my diagonal D. You can make it any variable you wish. Okay, the length of my legs are 10. So I know that 10 radical 2 is equal to the hypotenuse, which is my diagonal D. So the length of my diagonal is 10 radical 2 inches. I want exact answers when dealing with special triangles. Okay, problem number 2. Find the perimeter of a square whose diagonal is 4 centimeters. Okay, once again, I have a square, so I'm going to draw my square. Again, square has 4 congruent sides and 4 right angles. And in this square, I know that my diagonal is 4 centimeters. Now, I'm going to find the perimeter. The perimeter is all 4 sides added together. So in order to find the perimeter, I need to find the length of one of the sides. Again, this creates a special right triangle, specifically a 45, 45, 90-degree triangle because it's isosceles and it's right. So for a 45, 45, 90-degree triangle, I know my leg times radical 2 is equal to the hypotenuse. Okay. Now, I don't know the length of the leg, but since I know the diagonal, I know the length of the hypotenuse. So I have my leg times radical 2 is equal to 4. To find the length of the leg, I divide both sides by radical 2. So my leg is equal to 4 divided by square root of 2. I cannot have a square root in the denominator, so I'm going to rationalize by multiplying the numerator and the denominator by radical 2. Multiply straight across. 4 times radical 2 is 4 radical 2. Square root of 2 times the square root of 2 is the square root of 4. Now, I cannot take the square root of 2, but I can take the square root of 4. That's equal to 2. When I take the square root, the symbol goes away. And then 4 divided by 2 is 2. So the length of one leg is 2 radical 2. Now, if one leg is 2 radical 2, then they are all 2 radical 2, because a square has 4 congruent sides. So to find the perimeter, I add up all the sides. Since all of the sides are the same, I can just take 4 times each side, 2 radical 2. Again, 4 is not inside of a square root, and 2 is not inside of a square root. So I can add those together. Multiply those together. 4 times 2 is 8. So the perimeter is 8 radical 2, and that would be centimeters. Problem number 3 says one side of an equilateral triangle measures 6 centimeters. Find the measure of an altitude of the triangle. Now, altitude is a fancy word for the height. I'm going to find the height of the triangle. Now, an equilateral triangle is a triangle with 3 congruent sides. But in an equilateral triangle, I also know I have 3 congruent angles, all of which measure 60 degrees. Now, one side of my equilateral triangle is 6 centimeters, which means all of the sides are 6 centimeters. Find the measure of the height. Now, I need to draw in the height. It's the perpendicular distance from the vertex to the opposite side. Now, the height cuts the angle in half. So that's a 30-degree angle. But it also cuts this base in half. So half of 6 is 3. So what I have right here is a 30, 60, 90-degree triangle. I know my hypotenuse is 6. The shorter leg is across from the 30-degree angle, so that's 3. I need to find the height, which is the longer leg. Well, in a 30, 60, 90-degree triangle, I know that the short leg times radical 3 is equal to the longer leg. Well, my short leg has a length of 3. So I have 3 times radical 3 is equal to the longer leg, which represents my height. Okay, so the height of this triangle is 3 radical 3 centimeters. Okay, problem number 4. Find the height of an isosceles triangle with a base of length 20 centimeters and congruent sides of length 15 centimeters. Okay, so I'm going to draw an isosceles triangle. Isosceles triangle has 2 congruent sides. Okay, so this says find the height of an isosceles triangle with a base length of 20 centimeters. Okay, and I have congruent sides of length 15 centimeters. So each of my 2 sides is 15 centimeters. And I need to find the height. Okay. What happens once again is this creates a right triangle. Okay, if the whole base is 20 in an isosceles triangle, the height cuts the base in half, so the length of this shorter leg is going to be 10 centimeters. So what I have is a right triangle whose shorter leg is 10 centimeters and has a hypotenuse length of 15 centimeters, and I need to find the length of that height. Now, notice I don't know anything about the angle measurement, so I'm not sure if this is a 30, 60, 90-degree triangle or a 45, 45, 90-degree triangle. And when it's not given, I cannot assume that it is. So I know 2 of the 3 sides of this right triangle. Anytime I know 2 of the 3 sides, I can use the Pythagorean theorem. So I know that a squared plus b squared is equal to c squared. So you have to be really careful. Sometimes we get so caught up in the 30, 60, 90-degree triangle, we just assume without necessarily knowing the length. So if you don't know the measures of the angles, always resort to the Pythagorean theorem. Now, the side across from the right angle is 15 centimeters. That's my hypotenuse, which means 15 has to go in for C. And 10 and H then will be the legs. So I can go 10 squared plus H squared is equal to 15 squared. 10 squared is 100. Okay, 15 squared is 225. So to solve for H, I subtract 100 from both sides. I have H squared is equal to 125. Then to find the square root, we have, to find the value of H, we take the square root of both sides. So what I need you to do is take your calculator. I want you to find the square root of 125 and round it to the nearest tenths. And that will be the length of the height of the isosceles triangle. Okay. Now that we've gone through 45, 45, 90 triangle, a 30, 60, 90 degree triangle, and the Pythagorean theorem, I want you to go back and revisit problem numbers 5 and 6. Okay? In problem number 5, you're going to use the Pythagorean theorem. And in problem number 6, you're going to use a 45, 45, 90 degree triangle. Try those two problems again. When you are finished, I want you to pull up the solution sheet and double check your answers. Once again, if you have any questions, feel free to shoot me an email. If it's something I can't answer through email, I'll send you a Zoom link and we can spend a few minutes Zooming. Good luck.